Okay, once again, CLEP calculus practice exams that I found on the web. We're doing this one right now, the 60 question one, at these URLs that are hopefully still around when you watch the video. So we're going to get back at it with number 6 here. And it's saying that it's presenting you the graph of f prime prime or f double mark, whatever you want to call that, the second derivative. So this represents the second derivative of an original function. And so it's asking where on the original function is it going to be concave up versus concave down. So you have a nice shape here, but that doesn't really matter. What we're going to care about is where is this positive and where is this negative. Because a positive second derivative means you have a slope that is increasing, which means you have concave up. And a negative second derivative means you have a slope that is decreasing, which means it's going concave down. So it is positive between -1 and 3. It's up here above the x-axis, and it is negative less than -1 and negative at greater than 3. So with the positive second derivative here, that interval from -1 to 3 is where that original graph is going to be concave up with the increasing slope as it goes along. So the answer is D. So now we're being asked to integrate this mess of a thing. All right, so we have integrate of x minus 1 times square root of x dx. And the first thing we have to do is convert this to numbers we can work with, meaning the square root of x is going to have to turn to x to the half. And how do we justify that? Why does that work? Well, we know that if we have x times x, we get x squared. But what if we want to know what multiplied by what equals x in terms of exponents? So normally when you are multiplying exponents, like if you have x squared plus x to the third, that's really times, not plus, times x squared times x to the third. That's x times x times x times x times x equals x to the fifth. So what we're really doing is adding the exponents. So if you want two exponents that will add together to make 1, what is it going to be? It's going to be a half. X to the half times x to the half equals x. So the square root of x is the same as saying x to the half. And that gives us something we can work with. So now we're going to multiply this out. X times x to the half is x to the 3/2. And we're working in improper fractions just because that's easier to keep track of things. But 1.5 we know is 3/2 because 1 is 2/2, and you add across with the same denominator and you can get 3/2. So 3/2 minus x to the half dx. And now you're going to do the power rule in reverse. And this it gets a little tricky there. But remember that if we have, say, x to the fourth, and we want to take the derivative of that, we bring the 4 out into front and subtract 1 from the 4. We get 4x cubed. But now, what if we're taking the derivative or the integral, and there's no number out front, so you want to take the integral of, we'll say, x to the fourth again. Well, we know that we subtracted 1 from the original to get to the 4, so we're going to have to end up with x to the fifth. And we know that if we're going in that direction, taking the derivative, we're going to move the 5 out into the front. But then we somehow end up with 1. So what do we have to have there? We have to have 1/5, so that when you move the 5 over, it cancels out. And then you subtract 1 from there and get x to the fourth. So now we go back to this. The derivative of x to the 3/2 minus x to the 1/2. And you do the same thing. We figure that 3/2 plus 1, or plus 2/2, is going to be 5/2. And if we have to multiply by 5/2 to get from here to here and have 1 as a result, then it's going to be the reciprocal, 2/5. And same over here. To go from here to here, we have to subtract 1. So we would have started out with 3/2. And to go from here to here, we would have brought the 3/2 out in the front, but we end up with 1. So you have to start out with 2/3. 2/3 times 3/2 equals 1. So you get this, plus, of course, the c. And yes, pardon the sloppiness with the mixed numbers, but that's how it has it. And we can see that the answer we got corresponds to the A there, mixed numbers at all. So we're going to move on now to number 8. So it's asking us, we have two functions, f and g, the sine of x and the cosine of x, and for what value is the line tangent to the graph, the line tangent to sine of x at some value of x, the same slope, where they parallel, meaning the same slope. Basically saying for what x value are the slopes the same, the tangent line being parallel, meaning the slopes will be the same. And we know the slope means the first derivative, so it's basically asking at what x value is the derivative of both of these the same. So we're dealing with sine of x and cosine of x, but the derivative of the sine of x is the cosine of x, and the derivative of the cosine of x is the negative sign. And these are ones that you have to memorize. So now we're asking, at what x value are these equal? Or really, the x is the angle here because we're doing sines and cosines. So at what angle is the negative sign equal to the cosine? So we have to think about our unit circle here. slightly off center, and pardon my drawing, where of course we have 0 and pi, because we're working in radians here. So you have half pi up there, quarter pi there, 3/4 pi there, and all the rest, 3/2 pi there. So we also recall that from the definitions of sine and cosine on the unit circle, that the sine of the angle is equal to the y value, and the cosine of the angle is equal to the x value, in that the angle from 0 going that way. So if you have an angle of 0, you're here, and the x is 1, because the unit circle has a radius of 1, and the y is 0 because you're 0 above. But if you have an angle of half pi, now the x value is 0, and the y value up here is 1. And then if you continue on your angle all the way around to pi, your x value is -1, but your y value is again 0. And on and on. If your angle is all the way to 3/2 pi, then you have an x value of 0 again, but your y value is -1, because you're going around the circle. So kind of the trick here is that your sine values, being y, will be positive for all the angles from 0 to pi, and then negative for all the angles from pi back to 0 or 2 pi at that point. Whereas the cosine, you're talking the x values, is going to be positive from 0 to ½ pi, because you're on the positive side of x. And then it's going to be negative from ½ pi to 3/2 pi on the negative side of x. And then positive again for the rest of it from 3/2 pi back up to 0. So the question of where are they going to be the same value but opposite signs, because you're talking about the negative sign versus the positive cosine. And where that overlaps is going to be over here, because over here the cosine and the sine are both positive, and they're both in the positive side. But over here, the x, the cosine, is negative, but the sine, the y, is still positive. And at what point is just the number going to be the same? And that's the halfway point, because that's where you're making a square, with the radius being the diagonal. So that's where your x distance here and your y distance here are the same at the quarter points, between the axes. So the answer is going to be 3/4 pi. It could also technically be the one over here, but that's not one of the choices. The choices are just these. So you have 3/4 pi, and you could check the others against each other. Obviously at pi you have 1 and 0, and at ½ pi you have 1 and 0, so they don't match at all. And then a quarter pi, again, it would be the same numerical value, but the signs would be wrong because they both be positive. but then you're taking the negative sign that makes it negative, so they don't match at that point. So the answer is D. Okay, next question. And it's telling us that the acceleration at time t, t being, that's our independent variable here, what we normally think of as x. It's just going to be a t instead of a particle moving along the x-axis, meaning just moving in a straight line where x, t is your time and x is going to be your distance at this point. And that equation is going to be 20 t cubed plus 6. And then it tells us at time 0, the velocity is 0, but the position or the distance is 7. So where is it? Where is the position at t? So the key concept here is the relation between distance, position or distance, and velocity or speed, and acceleration. So your velocity is how your position is changing over time, and that's exactly the way that the first derivative is describing how the function, the height of the graph is changing over time, meaning the slope. You think of the slope, you think of the slope as how much greater y is getting as you increase your x, how much greater is y getting, and that's your slope. But we can also call this distance, well, time rather, and this distance. So if you're starting at some point and you're moving forward as time goes on with increasing time, you're getting farther and farther away from your starting point. And if you're moving very quickly, you're going to have a high slope, and if you're moving slowly, you're going to have a lower slope. So the distance, the speed, the velocity, is just the slope of the time versus distance graph, meaning speed is the derivative, the first derivative of the distance. And we can repeat that again. The velocity, the acceleration. Well, acceleration, we're asking, how is the speed changing over time? If you're increasing speed, if you're getting faster as you go, then that means you are accelerating. And if you're moving but you're slowing down, you are decelerating, or a negative acceleration. So that's telling you, your speed tells you that you're moving, but your acceleration tells you that your speed is changing or staying constant or whatever. So how the distance changes with time is your speed, but then how the speed changes with time is the acceleration. So if distance is your original function, then your speed is the first derivative, and your acceleration, pardon my handwriting, is the second derivative. So now how do we use that here? So we know that the acceleration is this. So the acceleration. We're going to call it f double prime because it's the second, we know it's the second derivative, equals 20t cubed plus 6. So we want to find the integral of that to reach speed. We take the derivative to go from speed to acceleration, so we take the integral to go from acceleration to speed. So a simple power rule, we know that we're going to add 1 to the exponent. We're going to end up with t to the 4th. And so what did we multiply with 4? We would have brought the 4 down here to get to 20. So what has to be there? 5, because 4 times 5 equals 20. And the next one doesn't have a variable, which means you're just going to put it there, t to the first power. And then there's going to be that constant, that unknown constant. But we were told that at t equals 0, the velocity is 0. So f of 0, we know that this whole thing equals 0. And if we plug in the value of 0, 5 times 0 to the 4th plus 6 times 0 plus c equals 0. Well, that's all 0, that's all 0. Whole thing's got to equal 0. So the c is also 0. The c just isn't there. So our final answer for the speed or velocity is just 5t to the 4th plus 6t. But now we have to do it again because we want to know the equation for the position. So we're going to take the integral again, because to get from the position to the velocity, we take the derivative. So to go from the velocity to the position, we take the integral. So again, power rule, you have t to the 4th. So we know we're going to have to start with t to the 5th. And if we bring the 5 down into the front to take the derivative, and there it is. So it's just a 1 there. I won't write it. And then here we have 6t. So we know that we would have started with t squared, because you're subtracting 1 to get from here to here. And we would have brought that out to the front. So 2 times what gets you to the 6? You're going to have a 3. So 3t squared, and you're going to have that c again. But we were told that at t equals 0, the position is 7. So at 0, that all equals 7. So again, if you fill in 0 for this, 3, 0 squared plus c equals 7. Obviously, that goes away. So c equals 7. So your actual final equation is going to be t to the 5th plus 3t squared plus 7. Let's write that down here. So, but it's also asking us, well, that is the answer. What is the position of the particle at time t? And we figured it out. It is t to the 5th, 3t squared plus 7. It's d. Okay, moving on to number 10. So we have a function sine of x over 2x, and what is the derivative of that whole thing? So sine of x over 2x, what's the derivative? Now you have basically one thing up there and one thing down there. This is going to be a case of the quotient rule. And that's another one of those things that you just have to memorize basically. So the quotient rule says that if you have a function f over a function g, and you want to find the derivative of it, and that you end up with the derivative of f times g minus f times the derivative of g all over g squared. So what is our f and what is our g? F is the sine of x, and your g is 2x. So what is your derivative of the sine? That's your cosine. What is your derivative of g? And that's just going to be your 2. And now you have to put all those back into this. So you're going to have the derivative of f, the top, cosine of x times the bottom, the original bottom, 2x, minus f, the original top, sine of x times the derivative of g, the bottom. That's just going to be 2 all over the original bottom, 2x squared. So now that's still a bit of a mess. So we have to simplify that a little bit. So for starters, we'll just bring those out into the front. 2x cosine of x minus 2 sine of x. And then 2x squared. 2 squared is 4. X squared is x squared. But then you notice that we have a common factor among these. We have 2's and a 2 there. So we can write it out. 2x cosine of x minus sine of x over 2 times 2x squared. And we can just kind of cancel those out. And we're left with x cosine x minus sine of x over 2x squared. And that is your answer, selection B is the answer. So that's a pretty simple one in terms of the quotient rule, but you do have to basically have that quotient rule memorized in order to carry that out and determine what you get with that.